Hey folks, my name is Chuck Black. We are doing 52 weeks of Python. We are in week number 58, and what we're going to talk about today is a little bit about the topic of hacking. Now, as you can see over here, there are multitudes of videos and websites and blogs, etc. about security and hacking. These from David Bombal. There are from many others. I'm not going to attempt to recreate what has already been done, but my goal in this class is to make you into a legitimate software developer, not just someone who writes a Python script or copies and pastes stuff. So what we're going to do is we're going to learn some more Python, or we're going to apply Python that we know to the domain of hacking. And so this particular topic that we're looking at today has to do with cracking passwords. The idea being that if you've been given a password that is hashed in some manner, how can you find out what that password actually is? And so there's a number of ways to attempt to figure this out, and the way that we are going to address today with the code is going to be a dictionary attack, where we actually use a dictionary of well-known passwords and often used passwords and figure out if the hashed one is actually one of the well-known ones. Now, one thing I want to point out is this whole hacking stuff. I'm not going to be teaching you for the lessons that I do on hacking. I'm not going to try to recreate stuff that's already been done, but what I want to do is I want to describe how we might utilize this distributed Quokka idea in the context of doing some amount of hacking. And so I've speculated on creating a couple of applications that would run remotely, one called Snooper, one called Blabber. I'll talk about those as we get into the lesson, but I'm talking about this eventually in the whole domain of how we would do this with Quokka. Today, though, we're just looking at some code that actually fits into our 52 weeks of Python. You can see I've got module 14 right here, and I've written an application called Find Password that actually looks at finding the password doing three different ways. You can look at it over here. The first one is using the file read option, which is what everybody does online. A second is I create a dictionary, pay an upfront cost, but then the searches are super fast. The third one, since we know how to do databases, is I use a database, and I fill up the database with these passwords, the hashed passwords, and then I can easily do very fast searches to find out if they're there. And the data is persistent because that's how databases work. Anyway, I'm getting ahead of myself, so let's get started with this lesson on finding passwords in a dictionary. Okay, so let's get started talking about hacking. Specifically, we're going to look at cracking passwords. Now, as you can see from my screen, from this small sample of web pages to which you can visit and gather tons of information, the pool of people providing information about cracking passwords, hacking, ethical hacking, etc. is quite large. So there's many people who have provided lots of information. I'm assuming most of it is quite good and of high quality. So I am not going to be attempting to recreate all of that information for you. Rather, what we're going to do in this lesson and in any lessons that I do on hacking, password cracking, etc., is I am going to teach you how to become a software developer using this particular domain of hacking, password cracking, etc., as a means to teach you stuff. As you can see here in this picture, I have taken my Quokka Prime, this Quokka Prime that we've been working on. This is the picture that I showed you when we talked about distributed Quokka, and we talked about how important it is to have distributed solutions so that you can offload work for many different reasons. And one of the reasons is going to be, as we shall see as we go forward in weeks ahead, distributing the work of actually discovering things that we might want to discover, attempting to do attacks that we might want to do on the network in order to determine the level of security for devices in the network. And so what you see here is a picture of Quokka like we've had before. Here's the Quokka server. Here's the user interface stuff that can be running anywhere that you want it to run, because remember, it uses HTTP to get its information. Here are my remote workers. Now I am still showing them running on Raspberry Pis. You can run them on anything that you want to run them on. I just purchased a Raspberry Pi for the first time, put it together, and I'm running the worker and the monitor stuff, which you see not in green. All of that is running on my little Raspberry Pi and not even working it very hard in order to do that. And so this is really speculative what we're looking at here. We could put different types of hacking or vulnerability testing or penetration testing, whatever you want to call it, functionality distributed throughout the network. We can use functionality down here at the server to maybe do a deep investigation, trying to crack passwords, let's say. That would be a good location for doing that type of stuff rather than out here. And many other things, orchestrating the whole process. So you can have functionality running here. You can have functionality running out here on your remote devices as well. And if I do end up implementing this, we're not going to be implementing this today in this lesson, but if I do, this is probably how I would end up doing it. I would use the worker functionality. I'd send a message and say, hey, I need you to sniff for passwords for this particular user, this particular protocol, this particular conversation, whatever it might be, and we would get started doing that. Now, you're probably looking at this and saying, has Chuck gone insane? What is this thing called Snooper and Blabber? Well, you can look it up. If you look it up on Wikipedia, Snooper and Blabber was a cartoon that I watched when I was a young pup. That'll give you an indication of how ancient I actually am. Snooper was a cat, Blabber's a mouse, and I thought those two words were somewhat representative of what you might want to be doing in a penetration testing, hacking, vulnerability testing, etc. environment. Snooper represents the idea of like sniffing for traffic and snooping to find potential passwords that we can send back and attempt to crack. Blabber would be things that we could do, such as doing a denial of service attack, or maybe a brute force attempt to get access via a particular open port on a device. And I just said open port there. You'll remember that one of my monitors is port scanning, so I know what ports are open in each one of these different networks. And so I can target those devices on a particular port and attempt to connect to them. Anyway, this is what I am envisioning. So I want you to have that in the back of your mind as we begin to go through some of this stuff. Now, I have a number of things that people have asked me to address, a number of topics in Python. So what I probably will be doing, just as a heads up, is doing a little bit of this hacking-ish stuff and a little bit of the other stuff, like maybe Kubernetes or Jinja or Yang or something like that. But I will be attempting to look into this and to understand how I could implement it in this manner. As you can see, the goal here is not to recreate the stuff that you've seen here or here. Besides, I'd need to get a cool picture, which I clearly don't have in order to do this. So basically what we're doing instead is we're attempting to make you into a real live software developer. So you're going to be learning new stuff. I think that I probably would put queuing functionality in here and maybe some other Python things that I haven't addressed yet. Anyway, that's my goal. I just want you to be aware of that. And now what we're going to look at is going to be a password a detection or cracking functionality that I've created that we can now look at. Okay, we're going to look at the code and what the output of running the program looks like. But before we do that, just for a second, I wanted to give a shout out to our friends Snooper and Blabber. If you look for images of Snooper and Blabber, the cartoon that I referenced, then this is them. So This would be Snooper, the cat, and Blabber is the mouse. You can go online and waste a whole bunch of time watching episodes or pieces of episodes or whatever this might be. And of course, they have their own Wikipedia page. So if you want to know more about the real Snooper and Blabber, feel free to check those out. Okay, so let's look at the code. Now, I've created a new module. It's called Module 14 in my 52 Weeks of Python. I think this is going to be week number 58 when it comes out. I'm calling it Password Dictionary because basically what we're trying to do is we're trying to crack passwords using a dictionary. The general idea here is that you get a password which has been hashed and you look it up in a dictionary of well-known passwords. So the most common one that people tend to mention is rocku.txt. You can download it from online, and so that's what I've done. And I have a Python module that I've created, a script, a program, whatever you want to call it, called find password, and that's what we're looking at here. What does it do? Well, this is where I'm doing things a little bit differently. I mentioned I'm not attempting to reinvent the wheel. There are many different places where you can go online and see people using the rocku.txt or other mechanisms to crack passwords. What I'm doing is I'm attempting to teach you Python, and the domain or the vehicle that I'm using to do that in this particular lesson is going to be cracking passwords. So what you can see here is I've got three, I've run my program here. I have one option which is called my file read option. This is what you find online almost exclusively. I've extended that to use a dictionary option, and we'll see what value that gives and the downsides as well. And lastly, since we've learned about databases, I'm going to use a database option for doing this. Now, if you were to create a real live in the wild password cracker functionality that is actually attempting at larger scale to do password cracking, not just for one password, but for many of them, you probably would want to be doing something similar to this, what I've done. And so we will look into all three of these, and that's what the code is going to look at. Now, let's see, I think you'll see here, basically I'm looking for this one particular password. When I did the file read option, it took me 9 seconds to do that. When I used my dictionary option, it took where is it? At 0.00009. I may have forgotten a zero in there, seconds to do that. But there are downsides when I did it from a database. So this is a database with 19 million entries, and this took 0.005 seconds. So you can see that's many orders of magnitude faster than just doing a file read. And if you're to do this at scale for large numbers of these, you definitely want to be using one of these options here rather than using just reading it from a file. So I'm going to be teaching you a little bit. We're going to be exercising what we've already learned actually in terms of our Python skills in order to augment this password cracking mechanism. So that's what we're going to do. Let's take a look at the code. So as we normally do when we look at this code here, this is my find password module. Let's take a first pass through the code at a high level and see what it's doing. So this code is only 93 lines. I'm doing all three of the methods that we just talked about. Here is my find file read option alternative right here. And just at a high level, what are we going to do? We're going to allow the user to type in a password. We're going to hash the password, and then we're going to go through the password file, and we're going to compare that hashed value to the hashed values that we are getting from the passwords that we're going through in this particular file. So we're going to go through the entire file if necessary, and we are going to see if there's a match, and if there is, we're going to say found it, and if there's not, we'll say that as well. Now for the second option, it looks like this. So here is where it begins. This is finding passwords dictionary option. Now one thing that you'll notice is this beginning part is I'm actually going to have to build my dictionary. So this takes a fair number of seconds. I can't remember exactly. For 15 million, it may take a couple of minutes in order to do this. So I need to build it up, number one. And number two, what you will see is, and this is why I have this here, my memory is going to begin to skyrocket. That's why I have this code here that says I'm only going to look through a certain number, because I found when I went beyond this number, what ended up happening was Linux, Ubuntu ended up saying, I don't like this program, it's going to crash the operating system, and so it crashed my program instead. And so I needed to set an upper bound on what I was going to do. But there's two steps. The first is to read it in to the dictionary, and then the second step is to do exactly what I did before, but you'll notice, or perhaps you'll see it when we go through it in greater detail, all I really need to do is say, is this hashed password in my passwords dictionary? And if it is, then we found it. And that, as you saw, happens almost instantaneously. So it's very, very fast. Now, the last option is going to be the database option. So, of course, this is like for, big adult software developers. Because we're using a database, I chose to use Mongo. This Mongo database, I'm doing the same types of things that we have done with Mongo before in our previous lessons. So you know how to use Mongo. It's very straightforward. It's very flexible. So basically, you create things on the fly. So if I've not created this password database and the collections within it already, then it will do it for me. So this documents db.passwords, that is going to be created if I haven't done it already. Now, I don't want to do this every time. Just a quick look back here at the dictionary. I need to do this every time I run my program. Now, what you would do if you were using a dictionary is you would start up your program, you'd let it load everything, and then you would run your program forever. It would just sit there, and it would not have to be rereading it in over and over again. So this is a one-time cost. And when you become a more advanced software developer, you realize you need to understand one-time cost versus every-time cost. This thing that we do here, where we go through every single one of these, if you were to become an advanced software developer, you're going to need to know about the downsides of doing stuff like this. For me, over here, when I did one search with my file read option, it took 9 seconds. That's not a big deal. If I'm attempting to get 10,000 of these passwords cracked, then it becomes a big deal. And so rather than paying this cost every time, you end up paying the cost one time, which is where you'll see that we create this. And then from that point forward, everything happens almost instantaneously. So one-time cost versus having to pay the cost every time. That's something you need to know as a software developer if you're going to be building real software. All right, so that is why the memory thing is an issue here. That's why we did that. Lastly, we're down here in the database code. I don't know how I got back on talking about that, but we did make it all the way down to the database code. Here's where I create the database code. Now, this is really important for those of you that are not familiar with databases. If you want to be able to do searches of database like I am going to do, when you see down here, this is our Mongo method that we call in order to find something, and we pass in the search criteria. If I want that to go fast, as it has in this example that we see over here, if I want it to be fast, then I need to pay another one-time cost, which is to create an index on my database. When you begin to do, I'm hesitating to say big boy software because that's gender specific, and since we live in a patriarchal society, and that's kind of a bad thing, I want to do a gender neutral, but I don't, a big person software, maybe I'll use that. But when you get to the point where you're doing real live software, you will be creating indices on your database tables, and it will be the thing that you think that you are going to be searching for. In this situation, you'll see I create my index on this field called clear, which is the clear text password. I'll give you a hint. When I came down here, I've actually changed this, so I'm actually doing a search for the hashed field. And guess what? If I just created an index on clear, that would be really slow. Behind the scenes, I've gone and created the index using the Mongo command line interface, but probably what I should do here is change this to hash, because that will be what we're searching on in a more real world situation. And here again is my code. It's very simple. Notice up here my code, I have a for loop, and I have to go through all of these particular things and find out if the password is actually in here. Oh no, sorry, this is where I'm creating the dictionary. Let me go up. This is my for loop that I meant to do. This is where I'm finding passwords in my file read option. Maybe I'll go back and try to edit my mistake out there, but you can see here is where I'm doing the file read option, and this is my for loop where I go through here and I look at everything one at a time as I read the file one line at a time. And down here, as you can see, all I need to do is a single if statement. I don't have to have a for loop. And down here also, when I get to my dictionary comparison, all I need to do is my find for the dictionary, and then if it found it, which is this test right here, then I print that out. All right, so that's a high-level overview of the code. Let us see what it looks like when I run it. Okay, so let's get started actually running the program here. The program is I'm running find password.py. It's going to ask me a password to search for. Now, in a real-world situation, what's going to happen is your program will be given a hashed value, and you will be looking it up against hashed values of passwords that are in the password dictionary. In my situation, I don't want to have to either type in a hashed value or always be copying and pasting hashed values from elsewhere. So I'm just going to type something in here. So I'm going to type in ABC and let it search for it, and sure enough, it found it pretty quickly in 0.2 seconds. So that's good. If I was going to type in something else like Augie Doggy, see if it finds that. I'm not even sure if that is actually in the dictionary, so it will take a while to find it. As you can see, it's going through all of the different entries in that password file, and when it gets to the very end, it will end up saying, I didn't find the password, and so it will end up printing out something to that effect. There, it says it found it, and that actually found it. Wow, 9 million different entries it had to go through, but it eventually found it. So you can see how long that took, 27 seconds if you're looking for passwords. And that's only, well, that's what, 9 million. So we go up to like 15 million in this particular file. If you have even more than that, you can see how long that would take. Now, the one password that I tend to look for, because it's right at the edge of something, I'll explain it in a minute, is this password, Serena0015. Now, this one is going to take, I think it takes a couple of seconds in order to find. Let's see how long it takes. There it is. It took, well, okay, I was wrong. It took 11 seconds. And so basically in 11 seconds it found it. It's right at this edge here. This is the edge of 4,000 different entries. And why is 4,000 important? It's just arbitrarily important for me. And the reason is this. I'm going to hit return here, and I'm going to go to the dictionary option. Now, you can see I've already used up close to 60% of my memory. What I need to do to make sure there's room for this dictionary to get loaded in my smallish machine is I'm going to close my PyCharm. And what that should do, you should see this value here begin to go down. Okay, you can see it's down below 40 at this particular point in time, so that's good. What I'm going to do now is I'm going to allow the number of passwords to add to the dictionary to be 4 million, and that will keep us underneath the limit of how big my program can grow. So this will take a little while, so I'll probably speed it up, but I'll tell you how long it took when we come back. As you can see over here, that the actual memory usage is beginning to grow. Now, when I ran this the very first time, I did not know that it was using up this much memory, and it ended up crashing on me. And I think what I ended up doing, because after it crashed, I was able to see that memory had gone up near 100%, and when Ubuntu terminated my program, it went back down to 40% or whatever it was. So that's when I knew that I had issues that I would need to deal with. So you can see it's grown from about 40%, it's up around 60%, and we're nearing getting 75% done with our 4,000 entries. And now I'll explain to you, this is why I found this Serena 0015. It's close to 4 million. Did I say 4,000 earlier? I meant 4 million. It's close to 4 million entries. So it's 3.8999 million in the list of items in that file. And so I'm going to allow this to get to 4,000. And now let me show you. I'm going to type in ABC. And ABC, it found in 0.000011. Now let me type in Augie Doggy. Now remember, up here it found Augie Doggy, but that was at 9 million. I'm not going to find it. So what happens if it doesn't find a particular password? Well, guess what? It didn't find it, but it failed immediately. So you're not paying the price of having to wait for a super long time. So now let me do my Serena 0015, and sure enough, it found it almost immediately. So it did not take very long at all to find it. 11 seconds versus 0.000010. You can do the math and figure out how many orders of magnitude that is, but it looks to be, what is that, 6 orders of magnitude or something like that. That's a lot faster. So that's the bottom line there, is that this is much faster. Now you can see my memory has stabilized. It's not going up or down. It just sits here. So I would be perfectly fine running my program forever like this. I wouldn't have to pay the cost that we paid when it was loading this. It did take about 2 minutes to load everything in. We would only pay that once at the very beginning, and then you would run your program for days or weeks, your password cracking program for days or weeks, and you paid the price once up front, and then from that point forward, you never pay it again, and all of your results are almost instantaneous. So that is the dictionary option. So I'm going to come down now, and now we're doing the database option. Now, in the code, we'll look at this. In the code, I don't build the database if it's already been built. So the good news is it has already been built. So I can just type something in. I'll do ABC, and you can see it found it. Even though it's stored in memory, the database it's stored on the disk. So it's stored in the file system. That's crazy that it can be that fast, but it really is. I didn't use up any memory when I began to run the database stuff. It's all stored on the disk, and yet it is super fast. You can see how fast that is. So let me do Augie Doggy. And once again, this time it can find it because the database has all 15 million entries in it when I built it, and it found it very quickly. So that's good. And of course, our thing that we were, Serena 0015, just for completeness, you can see that also was very fast as well. So this is the running the program for these different examples. And I think if I hit enter here, then it exits the program. So at this point in time, I've exited the program. What you'll see, notice this over here, the memory has gone way down. So you can see how much memory I chewed up. This is a 6 gig virtual machine, so it's pretty large, a large-ish virtual machine, and it was using a lot of memory in order to do that. Anyway, let's take a look at the code. Okay, let's look at this code one approach at a time. Remember, the first approach was where we just read from the file, and so that's what this is. This extra space down here, I just did it so that you won't get confused as we go through here. So this is the code that implements the file read option, what I called it. Basically, what we're going to end up doing is we're going to go through and get the input. This is the password that the user is going to type in. You'll notice that if you just hit return here, then it goes to it exits out. So that's if there's no in password. If that's none, then we're going to break out of this while loop. So that's what we do. We take the password that came in and we're going to strip it of anything before and after. Now, normally for somebody typing stuff in, that's not going to be necessary. So you may say that this is just extra, but it is important to do that when we read through the file one line at a time. So I went ahead and did strip here. So here, what I'm doing is I'm using this library called HashLib. You can look at all the different ways that you can use this, different methods that are available. I'm just doing a simple MD5. Yes, I know that it's an insecure method of encryption. I'm not trying to be the encryption god or goddess here, just trying to show some hashed values and demonstrate how we would do a dictionary lookup. So we take the password, we strip it. Now, just taking the password and doing hex digest may have been okay, but I needed to do encode on this password file, the entries from the password file, because they can have strange characters in them or unexpected characters in them. And so basically what I do is I just call this encode UTF-8. Again, something that I could probably get away with leaving out if I wanted to, but I have it in there for consistency's sake because I need to do that on the rocku.txt file. So basically I'm going to end up with a hashed version of this, and now I'm going to go through this entire file. I'm using a with statement to open my file. Here's an important thing you need to be aware of this. Do you see where I'm getting this rocku.txt file? Two things. First of all, think of it just as the rocku.txt file. If we were to look in my directory down here, look at what I have in my directory. The only thing I have in it is find password.py. I don't have the rocku.txt file in there. Why is that? That's because I don't want Git to think that it always needs to save the rocku.txt file. And I know I could probably have manipulated git ignore to get it not to worry about that, but instead I just moved it to another location. So the only thing in this directory in the M14 password dictionary is my find password Python code. So it's going back to get it. The second thing that you'll notice is that I actually had to do some manipulation of this file because I was getting an error with rocku.txt as it was when I tried to use do this HashLib stuff on it. And so basically this is what I ended up doing is I Googled it online. I cannot recall exactly what I did, but if you get an error trying to use the rocku.txt file, then you will find, if you Google the error, then you will be able to find how to run the conversion. And, I'll look up the command that I used to do that. Hopefully I have that stored still. But I open the file, and then here's what I do. This is my long for loop, so it's going to go through every single line in that file, and it's going to compare my hashed password, that's this one right here, with the password that I'm looking at that I got from the file. Remember, I'm going through the passwords file and calling it password. I'm going to hash that on the fly, and then I'm going to compare this against that. And so if they're equal, then I say I found it. And if I continue to go through all here and I get to the end of my for loop and I have not broken out of it, here's this else statement. Pay careful attention, all right? I've had questions on this before where people think that I have indentation incorrect. This else statement goes with this for statement, all right? This is a unique construct in Python that I think is quite handy. After 40 years of having to do flags that told me whether I found it or not, I find it to be very useful to have something like this. So if I'm going through a for loop looking for something, all I need to do is break when I found it, and then I get out. And if I go through the entire thing and never find it, then I can do this, and that's where I print that I did not find that password. So this is pretty straightforward, just going through it. Obviously, it's simple and easy to do. Sometimes if the thing is at the top, and remember rockq.txt, I didn't tell you this before, but it orders the file based on popularity of the password, so you have a better likelihood. If it's something like ABC, it gets found pretty quickly. If it's something like Augie Doggy, you have to go through almost 30 seconds of reading through this entire file and hashing every item and seeing if it's the same. So here you see a really long delay, and even for something that is only 4 million entries into this file, it took 11 seconds. But it's simple and straightforward, and it works for cracking passwords that actually are part of this 15 million well-known and often used passwords. So that is finding passwords using the file read option. Okay, so let's look at the dictionary option. Remember, in this situation, I pay the cost up front where I build my dictionary, and then the idea is that the program would then run forever, and you would get almost instantaneous match or no match. So let's look at the code that does this. Now, the first piece here is, this is where, remember, I had to worry about the maximum size because I was overflowing memory. Remember how this went way up high, and so we needed to make sure that we set this maximum number of passwords that we're going to read in. In a normal situation, if you're running this, you'd want to have enough memory to handle everything that you were going to do, and then you wouldn't need to have any of this. So this is all about how many passwords are we going to read in. It wouldn't be necessary if you have enough memory on your system. Second thing I want to point out is this. Look at how I've formatted everything. This is how I like to do it. I'm a little bit obsessive. I think that it reads nicer where I can see these things if they're indented, if they're in a different location. For me, that's a little bit harder to read, so I actually did this. I don't tend to do this in my Python code because PyCharm complains about it. You can see here, Python's even complaining about that. So what I can end up doing if I want to is I can say, hey, I want you to ignore an error like this. And so what will end up happening is there you can see the squiggly lines went away. And this is very easy and simple to read for me, but I know that it doesn't meet PEP guidelines, so you can do what you want. And the other thing is that I'm doing it on the same line just because I like to have things vertically compressed if possible, and if easy to read. You see I put in extra blank lines to help me to read it, but yeah, that's just my style. So here's where we're actually going to be doing the reading in of the dictionary. So what we're going to do once again is we're going to open up the RockU file. We're going to go through that file one at a time, and then what we're going to do, this is where I make sure that I'm going to quit if I have reached the end. In other words, I don't want any more than this. Again, if you have enough memory, you don't have to worry about this. Get rid of all of this stuff and get rid of this line as well. Here I'm just printing it out because I don't like to sit there and wonder if it's working or if it's hung. So that was when it ran, and if you recall it writing out entry, that number kept going up and up and up and up. You remember when I ran it, that's what this is doing here. And then the main thing is that I'm going to hash the actual password that we read from the file. And then, this is key, remember to do this correctly, I'm creating my dictionary with the keys are the hashed passwords from this file. So I won't have to hash these anymore. The actual hashed password is the key, and then just for kicks, I'm putting in the index so that I can know where it was. And also I have the actual password, the real value. And so that is what I'm doing when I'm building this thing up. And as we mentioned, it takes some time. But the payoff is right here. What you see, my while loop is much simpler. All I need to do once I've got my password is hash it. And then I can come in and say, is that key, is the hashed password, not the password. That almost sounds bad. The hashed password. If it's in my passwords dictionary, remember that's my dictionary up here, then bam, I found it and everything's good. And if I didn't, then I can print out I never found it. And so I don't have to iterate through anything. It's just a one-time random access find of this thing, and it works perfectly well and very quickly, as you can see from finding these things. And it doesn't really matter how far we have to go. Augie Doggy was found in 0.000017, ABC 0000011, Serena 0015 was found in 000010. So they all roughly take the same amount of time. And that is the way you do something like that using a dictionary. Remember, we would pay this cost up front one time, a couple of seconds, a couple of minutes to read this in. And from that point in time, we would leave our application up and running and just handle these requests and look them up in our dictionary. That's how you make things more efficient in software. Okay, here's the last one where we are using a database. So again, this is for more intense, more production, more professional implementations of something like this. And you would do this especially if you have multiple of these password dictionaries or means of doing things. You may want to consider using a database. Once again, the database is something where there will be an upfront cost, and then from that point forward, things will go very fast. As you can see over here, the numbers they're not nearly as fast as the dictionary, but they are very fast. You're not going to have to worry about looking those things up. And remember, this dictionary, I only was able to store 4 million because of my memory limitation here. I have 0 memory limitation issues because I'm storing it in a file when the file is actually a database. And so this kind of tells you the miraculousness of databases, how fabulous they are. But as we said, there is going to be an upfront cost. This is some of the Mongo stuff. Remember, we went through this before. We've been using Mongo for a while. If you are interested, and if you're just jumping in here and you don't understand it, you can go back and look up some of the lessons that I've done on database. I handle both SQL and NoSQL databases. So I do look at SQL Alchemy in the Python sense for SQL, and PyMongo, as you can see right here, for doing Mongo. And it's very straightforward and simple. Here's my client. Here's my database that I called PassDB. I created that in the Mongo command line. And now I come through, and if I haven't created this before, I need to go through this particular process. What is the process? Again, this is going to look familiar. I open the file, I go through the file one at a time, and then what I'm going to do is I'm going to create my entry, and this is called password doc, because in the Mongo terminology, a record in a database table is called a document, and in fact a database table is not called a table, it's called a collection. That's just terminology. You don't have to worry about that. But this is the password thing. What am I putting in there? I have a field called clear, and that's the password. I have a field called hash. That's the hashed version. Think about this. If I wanted to have a SHA hash or some other type of hash, I could put this in there as well, and then I would just have to index it on whatever I'm going to be searching for. And so in my situation, I'm searching for the hashed value, so I'm going to index this. Now, I'm going to pause. I'm going to ask you a question, and then I'm going to pause, and I want you to answer out loud. Well, if you're around other people, you don't have to do it out loud, but at least in your mind, I want you to answer, how long do you think this process took? Now, remember, this process up here that I did with the dictionary of creating it, that took like 2 minutes to write it in memory. This situation, I am writing stuff effectively to a file, and not only a file, but to a database. So all of the stuff that has to go on in building a database is getting done. And as you can imagine, it's going to be non-trivial. So how long do you suppose that took? If you guessed 15 minutes, you're way low. If you guessed an hour, you are also low. This is on my system in my VM, but it took multiple hours for it to create this. Now, the good news is I wrote stuff out. This is actually not perfect code. If you do run this code, you'll see, hey, there's a problem here in what it's actually writing out, but it did update every time, and so I could see what was going on. If you wanted it to just do a new line every time, you could just get rid of that line right there. But it does write everything out, so you get to see, all right, and you can see the index, so you can keep track of that. It just takes it a while to write the entire thing out. It took multiple hours on my system. However, let me point this out to you. Once I have it written out, when do I have to read it in again? And the answer to that is never. Let's go back here to the dictionary situation. When do I have to do this dictionary creation? Every time I run this program. So for me, running this as a tester, I ended up commenting this out so I didn't have to wait through it while I was debugging the database stuff, because it takes a long time. However, in the database world, when I create this, where is it storing it? It's storing it in the database. And what is the database? It is a file. It's part of the file system. It's permanent. It's not transient. So up here, this dictionary, it's transient. It comes, it gets created, and then it goes away when we exit. And that's why I made clear when you're doing the dictionary thing, make sure you write your program so that you do this at the beginning and then you never exit the program. You just do this while true loop forever, effectively. And in the database sense, I don't have to worry about that, because once I've created it, I am good to go. In fact, I can tell you, I created this. If you recall from earlier, what did I have this value? I had it set to clear because I was just testing against the clear text password. And then I said, oh, I need to go the next step and test it against the hash version. I didn't have to create this again. All I did was I went to the Mongo command line and I created an index external to this program on the field called hash, and it was good to go. In this situation, I changed the code, remember, so that it says hash. But if I were to then, if I had multiple fields here that was something different, I could go ahead and create indices for those. Anyway, I digress. That is the one-time cost, and it truly is one time. I don't have to recreate this every time I run the program. Now let's look at the code. It's very straightforward. It's exactly the same as before. Well, it's not exactly the same. I get the password, I hash the password, and now instead of doing an if statement, remember up here, I did this if statement right there. It's not quite that easy. I need to go through and I need to do this database query. So I'm not doing an if statement, I'm doing a query. And remember, in Mongo, if I want to find something, I say find me one of these, and it will either find me one or it will give me none if it can't find it. So I pass in this is what it's going to search for, this dictionary. And the key is hash, so it's going to look up in this field up here called hash, and then the value that it's looking for is the password that was given to us that we then hashed. And if this has a value, in other words, if it's not none, then we print out that we found it, and we print out the time that it took to find it. and then if we didn't find it, then we end up just saying no, we didn't find it. But again, I don't think I gave an example of one that it didn't find in this, but you can imagine the time is going to be pretty much the same as all of these. It's not going through it iteratively or serially. It's going directly to the index and seeing if it's there. So that is the database version. It's kind of more of a professional way of doing things, but if you have this in your toolkit and you understand how to do stuff like this, especially if you're like in a DevOps type environment where people only have marginal software development expertise, then this will put you leaps and bounds ahead of the rest of the folks. And if you're thinking of getting into software for real, then understanding back-end stuff, which is what we call database, is something you're going to want to do. So that's how we do it with database. Okay, let's review what we talked about. I started off by mentioning that I'm not going to try to recreate all this cool hacking stuff that's been done by David Bombal and many others. You can go online and find many different examples and things of that nature. Rather, what I'm going to attempt to do is teach you guys how to create software, and I'm going to do it in the domain of learning about some amount of hacking. So part of the idea is how would we build a hacking type application? We've done Quokka before, which does monitoring, and it does examination of the network using port scan, capture, traceroute, etc., and all of these different monitors that we have. For hacking, I'm adding this idea of snooper and blabber, which I described a little bit in the cartoon that they came from. And we will look at how we might do something like this, but really the main idea is to teach you how to write software in this course. And so this particular lesson, we're talking about software that happens to be password finding or cracking. And so the idea is that you've been given a hashed password, and how do you find out what the actual value is? Turns out that what's called a dictionary lookup is going to be your best bet, and so there are files out there called RockU and others that you can use that have well-known passwords, and we talk about the way that you can do it. And what I did was I talk about 3 different ways. One is by looking at reading the file one item at a time, this RockU file, and finding if there's a match. That's what most online website descriptions of how to do this do. Perhaps not the best for a real software environment. I look at a couple other ways to do it. Since we do understand software a little bit better, perhaps we look at a Python dictionary. And so this is using a Python dictionary. And then I look at actually, wow, this is a kind of a quantum leap forward in terms of software development. I actually take the passwords and I put them in a database, and we looked at how we would do that as well with the database. So hopefully that made some sense to you. We talked about, just to review, we did talk about how here you just get started going through them one at a time with a file read option. Here you pay an upfront cost, you pay a memory cost. So we looked at the memory impact. And then once you've done that, then your searches for this hashed password are extremely fast. With the database option, you also pay an upfront cost, which is actually pretty steep, but you then have a database that sits around and is there forever for anybody to use and for you to use as many times as you want. And it's also extremely fast. Hopefully this made sense to you and you have a better idea, not only a little bit about hacking and cracking passwords using dictionary type of mechanisms to do that, but also you've refreshed or perhaps renewed or maybe even learned a little bit about using Python to perform these tasks. As always, hopefully you are more educated than you were when you started, and if you do have questions, just let me know. Thanks for listening.